everyone. My name is Kasha Alvin Sali. I'm a member of Group 9, and I'll be taking you through the explainable AI techniques we apply to our models in generative attention-based mechanisms for fake currency node detection. My colleague is Kabogari Salim. Thank you very much. So I would start with why we apply explainable AI simply because we want to get model transparency and actually trust the models we get to develop. Then also understanding model behavior, that is understanding the prediction or the classification or the output of the model. Then also want to improve the model performance, and this is achieved whereby applying AI helps us understand the interior working of the model itself and see ways or devise ways of making the model perform better. So with the best performing models in our project where the GAT, the graph attention network, and also the vision transformer, the techniques we actually had to apply to them where the GradCam, saliency maps, counterfactual visual explanation, those were for the GAT. Then for the VIT, those were the attention rollout, GradCam, and the LIME technique. So the GradCam on the XI on the GAT, it helped us interpret the model by highlighting the most key points that influence the GAT's classification, and these were the security. These were the key points or the key features on the currency note, and they were all highlighted in red. As you could see, we have the security thread in red, also have the stamp in red, and other features that actually matter in the real currency note. Then we also applied currency maps, and these currency maps, you could think of them as the ones that consider pixels, input pixels, or you could also think of them as input features, and they are considered as salience maps or key points and highlighted, and they show us the contribution of the key points, and they are able to ascertain the biggest impact of each key point on the model's prediction. That would be in this case the GAT. So they were all highlighted in blue, as you could see. So the more impact of each pixel, the prediction of the GAT, that would mean the more salient the pixel or the input feature. Then moving on, we also applied counterfactual visual explanations on the graph attention network, and this simply helped us highlight features, if altered, would make the GAT misclarify an input image. That would mean if you input a real image, a currency note image, it would misclarify it as a fake note image. You should change one of these features, and these features were highlighted in blue, where you could see the Mahatma Gandhi's head in the center with the blue, the Lante denomination stamp on the bottom left, and then also some other features. And then for the VIT, we use the attention rollout, which is a new built self-attention mechanism that helps us come up with an augmented heat map on the currency note image to show which regions actually influence the VIT's prediction. So you could actually see most of them that were highlighted were those that were in the blue or purple, showing Mahatma Gandhi's head, then the Reserve Bank and other features such as the watermark, the steam on the top, then also the digital stamp, then also the security thread. These were given more attention, and those that were given less attention were those that were in the red and yellow. And then moving on to the LIME XAI technique on the VIT, it was applied to generate locally interpretable explanations by perturbing input images and then analyzing slight variations and how they influence the VIT's prediction. And then we came up with a simple heat map and to show actually how these variations or the regions actually influence the VIT's prediction. And these were all demarcated in the yellow wing. You can actually see. So where you actually see the regions are declared out in yellow, this contains a security thread, Mahatma Gandhi's head, the Lante denomination stamp, the denomination of the currency, and so on. Then we also applied the GradCam, and on the VIT also came up with a very heat map that shows the most concentration on these regions that lied in the blue purple areas, then there is concentration in the regions that lied in the red and yellow. And then for the least performing models, we had the RaceNet, supposed to be RaceNet, not RaceNet. That's a correction as I start with. And then the applications were the XI applications were the GradCam, LIME technique, sharp values, and so on. And then for the mobile net, we applied the LIME XI, GradCam, and sharp values. So for the RaceNet, the sharp values simply help us understand how the RaceNet model used these specific features to come up with its prediction, or you could think of them as prediction. So the features that were in red and yellow were those that were given, where you could see Mahatma Gandhi's head, then also the digital stampings in India and on the top left, then also the Reserve Bank. These were given more attention. Then those that were in green were given less attention towards this RaceNet model was classifying data, hence its poor accuracy. And then also we applied LIME XI application, and then we came up with a heat map that actually shows the regions or the areas that influenced the ResNet model's prediction. And then you could actually see that most of the sensitivity features were left out behind in this dark coloring. You could see, and it actually highlighted that some of these features that didn't actually contribute most to the right classification. So it only had part of Mahatma Gandhi's, some of the edges, and then some of the writings on the watermark, but it lacked out on the features, hence its poor performance. Then also applied GradCam. GradCam, as I had earlier told you, helps us visualize where the input currency or focus on the regions that the ResNet model based on in its prediction. It's supposed to be ResNet, not ResNet. Remove that T. And then so the ones in blue and the ones in red and yellow, in this case, it means that the model focused on areas that actually did not matter so much and missed out on the areas that were in the blue and purple, the features that were supposed to be used for classification. So hence it performed poorly. And then also applied the LAM application to the MobileNet V80. And these are the regions that influence its prediction in the red and yellow wing. That's why you see some of them are scattered in places that actually not supposed to be, and it missed out on the security, on like most of the key security features. It just got Mahatma Gandhi's head and then this numbering here, but it missed out on the land denomination, the denomination itself, the stamping, the signatures, and so on. Then the GradCam technique on the MobileNet model also implemented this one, and then we came up with a contour map that highlighted the parts of the currency note image that the MobileNet was focusing on as it was making its prediction. So these are contour lines, but then they represent these dense gradients. These dense gradients are represented as the red and yellow. You could actually see the mere scattered on Mahatma Gandhi's head, then some of the Latin denomination, and some of the other key features were captured. Some of them, but not the most important features. These were left out behind in the red and purple scattered contour lines, or you could think of them as less dense gradients. And then thereafter, the MobileNet V8 just classified, had some right classifications, but then during its prediction, it focused on the least significant part or the least important features, missing out on the most important features. Thank you very much. And then also went for the sharp values, before I forget, for the MobileNet V80. As Adair said, it helps us to interpret the model itself in terms of coming out with the currency note, the input one, and then also know how the model predicted. So you see it actually missed out on the most currency note features that were left, that were colored in green, and then focused on those that were in red and yellow. So focused on Mahatma Gandhi's head, then the Reserve Bank of Uganda, rather of India, and then some of the key security features were missed out, as you could see there in green. This coloring, you could see they are also white and blue. The security thread